Okay, we're going to work out now a lot of problems by using substitution. So again, at the beginning, I'll take you more through this, and as we go forward, I hope you can work more of these problems out yourself. I mean, this is not really that easy, but you can get the hang of it, right? You should be able to get it by the time we finish working out these problems. Hopefully, you'll have a decent idea of how to proceed. So again, here's the idea. This is the anti-differentiation form of the chain rule. You can very much see this is the chain rule piece, right? So again, the key idea here is guessing this function g. Once you get g, there's no more flexibility in the problem. It will work or it won't. If it doesn't, try another choice of g. It just may not work. Okay, so let's proceed. Here's my first problem. And again, the level of difficulty is going to increase. So hopefully work through this and you'll get the hang of it. Okay, so always I want to define fx here. And what you start looking for is, I want the powers here, and you'll see why I write it this way as we work out more problems here. Okay, so just go with me for the moment. I just have powers again. You're looking for the basic ideas here. And again, we'll work with this. Okay, so if I can't just integrate this, well, I guess I could actually, right? You could square this and multiply it by 10x and it would be a polynomial. So you don't need integration by substitution here. You could have just done this regular. You can understand what I'm saying. This would work normally, right? Square this term out, multiply by 10x, and in fact it would just be a fifth order polynomial and you could just integrate it in a regular way. Now let's practice this with substitution. And in fact, that's probably a better way for this problem. But anyway, let's practice the substitution on this technique or the change of variables. Okay, now I have it set up in this particular form. Now the key is, here's the rule. When you choose to use substitution, you have to use this rule. Everything has to match up. And that's the real trick. Now I've kind of color coded here to help facilitate this argument. Right? All the pieces have to match. And again, the key is once you choose this function g, everything has to fall into place. Now, I'm going to break it down because one of the problems I've noticed with students is they mix variables. Everything on one side, the only variable over here can be x, and on the other side, the only variable can be y. Now, you don't have to do it. I've just found that terminal flaw of people is they mix x's and y variables and they get stuck and they lose track. So this is just a way I've developed just to help you sort through that. Okay, so you cannot mix x's and y's. Keep x's on the one side, y's on the other side. Okay, now let's proceed with what we're doing. Again, I'm just clearing the page and this is what I had before. Okay, now the key here is I need to guess the function g. Now it's the chain rule, so y equals g of x, right? But I'm guessing the function g. Now look at this. Now I've color coordinated this, but you'll see. What is the function g here going to be? It's going to be the x material, right? The x material. Your choices would really be involve this side or this side. But you'll see why. We're going to pick this side, right? Because we're looking for composition functions. So it's the kind of thing we were doing with chain rule. So I'm going to pick this. Now, if you make the wrong choice, well, you try something different, right? But I'm going to pick this. Now, automatically, right, once G is picked, everything else is given. There's no flexibility. You have no choice in the matter. Take its derivative. This is the regular old derivatives, right? Just plug it in and take the derivative. Right, so I wrote all this down. Clearly 10x is what's coming out of this. I'm just trying to show you that all these rules of differentiation do apply. Okay? But we do have the derivative. And notice this matches up with gx. So we pick g over here, and we have to have gx match up. Okay, that's the key. So again, notice we're getting that table of information we did with chain rule. So here we're starting with g, we get gx, and now we have to come up with, in a roundabout way, we're going to come up with the derivative fy. That's over here. Now look what we have. This is what I need to determine, right? And I'm going to get that from this material over here. And it'll always work like this. So just match it up, right? Just match it up. Again, this is gx, so this is out. So fy is everything that is not gx. Do you see? Everything that is not gx is fy, right? Fy of gx, of g of x, right? It has to match. It will always work like it. It has to match this way. So everything is not this goes here. Okay. Now we just have to change the variable. So notice g of x is equal to this, and it equals y. So on the one side, right, I'm going to write it as fyy. Remember, I don't want to mix variables. F is a function of y. That's what when you write fy, that's what you mean. The variable is y. Again, this is calculus of a single variable, but that variable can change, right? Now let's work on the other side. Remember, this is a connection between x and y. This is a link. This disconnects x and y. So just as I say y equals this for x, I can say, well, that's what I have, y. So I'll replace this term, this x term, with y. And so it's y squared. And that's my function, right? It'll always work like this. So it's all about making the correct choice for g. Once you take g, you have gx, and you can get fy. Okay, and now, once we have this, we have our table g, gx, fy, and now I'm going to put that up here. All right, substitute here. This always has to be one of these basic integrals. I mean, you can have trick problems where you have substitution within a substitution, and yeah, okay, that's enough. I mean, you're really working too hard for that. I mean, you really are. So this has to be a basic, or should be. Again, you can have gimmick problems, but that's not what I'm going to give you. It's just going to be basic. So it's powers, sine, cosine, e to the x. That's what you're looking for here. Something you can integrate with basic techniques. And you just integrate that, and that would give you the f to finish off your table. So I'm just going to use the power rule, and I'm not going to write it all down. We should have this by now. So this is the case. But again, my problem wasn't given to me in the variable y. My problem was given to me in the variable x. Again, over this side, only have y variables. On this side, only have x variables. And I say that because, again, I see the test. People are mixing and matching. You're never going to get it. So I'm just going to, again, use my connection here. Right? I'm just rewriting it differently here. Right? I'm going to use my connection, and I'm going to shift everything back to the x variable. And that's it. You can now check that this is the generator by taking its derivative. Okay, and you'll see that it works. Okay. Again, notice I did the chain rule here to check it. Again, if you're using substitution, that's the anti-differential version of the chain rule. I'm using the chain rule to check the answer. And notice I have exactly the same data set over here as I would with the integration, because it's anti-differentiation chain rule and it's differentiation chain rule. But it all checks out and works. And it's a good idea to check your work because a lot of things can happen here. Now, this problem is a little more sophisticated. Each of the problems is going to up the level slightly. So let's try to follow this along. So the first thing we want to do is look at the function and put it in the correct form. Now, again, what we want to do is, again, you can see x has to be greater than -1 because you want what's under the square root to be positive. But the key feature is I certainly don't want the square root sign. Okay, so at the minimum, I want to get rid of this. Now, this is one of the things I want to point out. People make a lot of algebra mistakes, and this is one of the ones that occur most frequently. There's no rule that says this is true. And if you change the problem by making this mistake, you don't need substitution anymore. You've completely changed the character of the problem by making this algebra mistake. And again, this is very common in the class. So I'm just going to point out, don't do this. Don't invent your own math. Okay, but the feature I want to get to is I don't want the square root. I'm looking for powers, sine, cosine, e to the x. That's the first thing I want to note. And then the second thing is I want to write it like this. So what I want you to do is begin to anticipate what's going to happen here. I'm going to make this, now you don't have to notice right now, but this is what I want you to start seeing. This is going to be my g of x. Why do I pick this as g of x? Because I'm going to take its derivative. Notice it's going to be 3x squared. The key is I have the x squared over here, and then we'll just fudge it to get the 3 in there, right? So begin to anticipate things like this. I want this to be g, and this part here, relative to the constant. We can put it and fudge it in that. I get the derivative similarities over here. So that's the way to see it. Now, of course, we have to go through it all, but this is the form I'm looking for, and this is pretty helpful when working out the problems. Okay, so that's what I want you to look at. And notice I can't just do this using, now in the previous example, I could just multiply it out. I'm stuck here. I can't do this without substitution. I simply can't. You can't multiply it through and get it to work out. Okay, so again, this is the idea. I'm going to take this to be g, and then when I take its derivative, okay, forget the constant, but I'm going to get the x squared. Okay, so again, start to see that. Now the indefinite integral, this is my problem, and I can't do it with basic techniques, so I have to shoehorn it into the substitution formula. It has to match up exactly, right? This is what you're going for, right? This is what you're going for. It has to match up exactly, okay? It has to match up exactly. So the key, it always starts with picking the function g. Now I have it kind of lined up so we can proceed. So let me look at the next page and just rewrite it. Again, I want to emphasize I'm always going to keep the x variables on the left and the y variables on the right. Because again, I can't overemphasize this. People often mix the x's and y's. You can't do that. Okay, so here we are. So our first choice is going to pick the function g. So you guys make that guess. Once you have g, then find the derivative gx. Okay, so pause and give that a shot. Okay, we have to guess g, and looking over here, that's what I'm going to take. It does take a little practice, but again, you'll start to see there's only so many scenarios that can happen. So you'll begin to get a feel for what you have to choose. I'm going to be using composition of functions. So again, if you made the wrong choice, if you set all this to the 1/2, you'll take the derivative, you see you can't get it to work. But if I take g to be that, gx is, I just take the derivative. Again, I put in all the steps, but of course it's not that difficult. You have 3x squared. Okay, it's not exactly matching here, and that's the new feature of this problem, but we can deal with that. So I made the choice of g, and that forces me into the choice of gx. So if you look over here, I don't have the 3, right? I only have x squared, but I have to have 3x squared. It has to fit in this form. Now I chose g. That forces my choice of gx. So I have to have a 3x squared here. So what I'll do is I'll put it in and take it out. And this is the standard, if you will. This is a standard gimmick. Okay, this is a standard gimmick. Because 1/3 times 3 is 1, right, is 1. Now what I'll do is I'll put the 3 on this side, and I'll stick the 1/3 on this side. And that's how I get around that. So see, I now match up gx. I now match that term up. And everything that's not gx is going to be this term. Okay? So now, can you figure out what f of y is? Try that. Try it. If you can't do it, fine, but give it a shot. See if you remember how we did it before. See if you can do it, and then I'll come back. Okay, let's take a look at this. Okay, so now we need the fy, the derivative fy. Okay, and what is fy? It's right, what is fy? I'm just cleaning it up here. I'm just cleaning it up here because there's just too many other lines. Fy is everything that is not gx, right? So gx is here. I put the dot there to distinguish. Everything that is not gx is fy. So that's what it is. Okay? So everything that's not gx goes over here. So once we have this identified, we have to just simply use our data here and convert everything to the variable y, right? Because I want fy of y. Change the variable. Now, again, on the left side, y equals gx, so that's a straightforward substitution, right? And notice on the right, that's a straightforward substitution, right? Y equals x cubed plus 1. And that's my function fy of y. Now, there are some things that can happen there, and I have a later example, but again, you're going to work through this equation, y equals gx equals. Okay, so now I have this function. Notice it's a constant times y to the power, and that's what I'm looking for. And right, it's of the right form, and now I'll just substitute it back in here. And again, this has to be one of these basic integral types. Y to the power sine, cosine, e to the power, e to the x, right? This e to the y. It has to be one of the basics. And I'm going to integrate this using the basic integration techniques. Okay, so you can try it. Pause and see if you can do it. Okay, we'll take out the constant, right? And then we'll use the power rule here. Again, there's no flexibility. You have no choice. Clean it all up. Let's clean it up some more. Right, I'll bring the 1/3 in. Okay. And now again, everything over here is in terms of y, but I want the problem in x, so I'll flip to the other side. Right, I'm just going to substitute y equals x cubed plus 1 and get the problem in x's. Again, I like to keep it separated. I learned, again, I didn't naturally do this, but by grading a lot of tests, I learned that this really helps people. Okay, so I do recommend this idea. Okay, so now we have our generator, and we can take its derivative and see if we get back the original. Again, notice my choices. I have g, gx, fy, and in fact, f here. And so if we to check this, we're going to always need the chain rule if you're using substitution, because it's the antiderivative version of the chain rule. So we'll take the derivative of this, and you can try. Make sure you can check your answer. Okay? And you can see these are my same choices. It's just the chain rule backwards. I'm doing the chain rule again and again. I have my exact same choices of variables here, and it works out. So by definition, the generator is the antiderivative of our original function that we gave us. They gave us the original function fx. Okay, so again, it's just the chain rule. Interesting enough, right? So, okay, so there was a new feature. We had to introduce the constant, take it out 1/3 and 3. Now, here's another problem. Now, see if you can set this up, just a step 0, in the correct form, right? See if you can write it in a form that helps you apply the substitution technique, substitution rule. Okay, let's take a look. This is what I'm given, but again, this isn't particularly helpful. So let's try to simplify this. First of all, I'm going to get rid of the square root and replace it with a half. And then I really want it as a power. Well, there's no quotient rule, but anyway, I want it as a power. And again, why do I take this term first and this term second? Because if I take this to be g, right, its derivative is 2x. Okay, the x I want to match, and the 2 I can put in and take out again, just as we did in the last problem. Okay, now notice again, you cannot integrate this using the basic techniques. You are forced into using substitution here. You simply have no choice. So try to set this up and notice that you have to choose your g. So let me just start it with you. right? Looking at this, I'm anticipating where we're going here, okay? So let's look. If I have to use substitution, it has to fit this template. Again, I have to emphasize, it has to pair up exactly like this if you're going to flip it to this side. It has to be exact. So your choice is, okay, so work it out. Your choice is to choose G, and then there's no more choices. Once you choose G, and I want you to do this, you get GX, and then everything on this side has to be GX. Everything that's not GX is over here. So see if you can do GX and see if you can then figure out what the function Fy is, Fy of y. So pause it and see if you can do it. If not, again, I'll work it out and you can see. Okay, let's take a look. Again, the whole point is to pick G. Now again, I separate the x's on one side, the y's on the other. So let me just take this to the next page. Okay? So the whole point is I have to guess G. Now again, I'm kind of color coding it to make it a little easier. But I'm going to take G then to be the x material down here, x squared plus 1. Again, if it doesn't all work out, take a different choice of G, right? I mean, take a different choice. You'll eventually get the hang of it, but it is a guess. You are guessing. So once I have G, I have to take the derivative. I have to find the derivative gx. And again, this is just going to follow the usual rules. I'll stop writing these down in a bit, but I want to make sure you understand. You're using the usual differentiation rules, right? So here's my data. Now again, I have to have gx over here. You have to. It's math, right? I'm not asking your opinion of something. It has to be gx. If you choose g to be this is gx. This has to be gx. So I have to have 2x here. So how am I going to do it? I put in the 2, and I'm going to place that with the x, and the 1/2 is then going to go on the other side. All right? So again, if you're stuck, see if you can figure out what the Fy of y is. Okay, let me do it. I break down the 2, put the 2 over here, so this gives me gx, right? And everything that is not gx is Fy of g of x, right? So again, try it if you haven't gotten it. So I'm looking for Fy of y. Right? And I'm just cleaning it up a little bit. And again, the key here is everything that is not gx, I like to put the dot there for that, right? And everything that's not gx, by definition, right, is Fy of g of x. And that's what we have. Now at this point, we need to convert it to the y variable. So again, if you haven't done it, try. All right. So the left side is always pretty straightforward, right? Y equals g. You're just really using this equation for everything. Now on this side, right, you get y equals gx. That's the abstract version right here. And then on the right side, I'm going to also use this equation, and I'm going to use it in the particular case y equals x squared plus 1, so that converts, right? So here's my Fy of y, and notice it's a constant times y to a power. It has to be one of these basic prototypes problems. And now I'm going to simply substitute it, right? Clean it up, substitute it up here. And okay, you should be able to integrate this. Now some of these you'll see as we get more complicated problems, but give it a shot, integrate that, and then, start up the video again. Okay, so again, when I look at this, I don't have a choice. I have to use the constant rule, take the constant out. I have to use the power rule, right? Take out the power rule. I'm just going to clean everything up now, like the algebra. Clean everything up. Clean everything up. Okay, here we go. Now again, the difficulty is I have y's. I need to go back to x's. But again, I have a relationship between x and y here. So using that relationship between x and y, I'm going to shift everything back to x's. And that tells me my generator, right? And then I can take its derivative and check. So I'm just rewriting that last line again. That's my generator. If I take the derivative of the generator, I should get back my original function. And again, you can try. Okay, so what do we have? I've just put all the steps here. Again, notice I have to use the chain rule to take that derivative of the generator. And again, it's going to be the same data as I had working the other way, right? As I had working the other way. It's exactly the same data for the chain rule, because again, substitution is really the antiderivative form of the chain rule. Okay? Again, these problems are longer, but if you're doing it and setting it up right and being careful, no particular step should be crazy. Okay, now here's one with some trig. Okay, so try to set it up. See what you can do with this. Do the step 0, and if you want to go further, try to do this one. I mean, it really helps if you try to work along, because if you make a mistake, obviously you learn something from it. Okay, first thing I'm going to do is look at the function fx, right? What is that? Now, again, what we want to notice, sine squared is not really natural, right? This is just a notation. It really means sine of 3x squared. Right, that's really what that means. So this is better. And again, why do I write it in this form? Well, let's take a look at what we have here. If I choose, I'm going to forget the 3x for a minute, but the derivative of sine is going to give us cosine. Right? Now you could say I could guess cosine of 3x for my g. It's possible. I mean, it won't work, but you can try it. It's certainly not saying it's ridiculous and it's out of bounds. But you can see what's happening. This is inside the squared. So you have composition of functions here. And this can be the derivative of sine. Again, we have the 3's to worry about and so forth and so on, but okay, we'll get to that. One thing at a time. I'm not doing it exactly in the first step. I'm just trying to get it set up correctly so it helps. Now again, there's no way you're going to do this problem without using substitution. So if I'm using substitution, it has to fit into this template. It has to fit into this template. And again, I'm separating the variables. The x is on one side, the y is on the other. So again, let me rewrite this on the next page. So again, see if you can guess your g. And then once you have that g, you have no more flexibility. See, then you get gx by taking its derivative. Again, I really want you to try this. There's a feature here that people often miss. And then if you get gx, come back and see if you can get the function fy of y. So pause the video and try this. Again, I want you to try this. People have problems here, and I'll show you why. Okay, let me go here. So I'm going to take sine 3x, right? That's what I'm going to take g to be, because it's inside the squared, right? And I'm talking about composition of functions. So now notice, I have no more flexibility in the problem. This is your only place where you can exercise free will. Now, gx is by definition the derivative of g, right? So I just substitute in what the rule is, and notice I'm using the chain rule to get this. So did you get the 3 out in front? That's the question. Everybody always misses that. They just say it's sine, it's cosine, and it's just sloppiness. You have to use the chain rule to take the derivative of this. Now, I didn't put all the steps in because, well, you complain, and I hear it here, putting all the steps in. You're doing the chain rule with this, right? This is a separate differential problem. Do it on the right side of the paper, right? So you'd have sine, and then your gx would be the 3x. Your f of y would be sine y, and then you're doing the chain rule here. So make sure you're careful with this, right? It's fine to leave out steps, right, until somebody gets hurt. Okay, so be very careful about doing things like that. So this is just chain rule, and if you missed a 3, well, I mean, that's a big deal. It's not a trick. It's just because you're not careful. And notice, this is the first problem in this section where I haven't put out all the steps, and because I was trying to lure you into the trap, right, to show you why it's so important to think that out. But anyhow, so now I have my gx. And again, you see, this has to be gx to the right side of that dot. So I need a 3 in there. So I'm going to do the standard fudge. I'm going to put in the 3 and take out the 3. So the 3 will go on this side and 1/3 will go on that side. So see if you can then get your function fy of y, right? Okay, so I'm putting the 3 here, so gx matches up. Gx matches up, I'm good to go. And again, everything that is not gx, right, I'm looking for fy of y. Everything that is not gx is, by definition, fy of g of x, right? All this, anything that is not gx is fy gx. It just pairs up, it has to be. It has to be. So now I have to convert everything here to y. Again, if you haven't done it, give it a shot. On the left side, I'm just going to replace g of x is y. So now I have fy of y, which is what I want. And on the right side, again, I need y's. But notice what I have here, y equals sine of 3x. So once again, it just converts to a constant y squared. So again, that's what I want, a constant times y to the power. Okay? So this is what I have. And now I'll just substitute it back and integrate. But this is the correct form. This is what I'm looking for, right? Constant times y squared. That's fine. So integrate that and then convert everything back to x's. Okay, let's do it. I take out the constant, right? Constant rule. I'm going to use the power rule on this. Clean up the algebra. Bring the constant back in. Clean up the algebra. Now I have to convert from y to x. Right? This is my connection up top. And there you have it. All right, x is on one side, y is on the other. This is my generator. And we can check. We're going to take the derivative here, right? Take the derivative here and see if we get back our original function. So this was the last line, right? And again, you can write it like this, you know, put the cube in it, sine cube, that's fine. It's not, I don't know, 6 1/2 a dozen the other. That's my generator. So we'll check, and again, take a moment to check. I mean, it's good practice. Take a moment to check. Again, if you had missed the 3 earlier, you would have had a problem. So take a moment to check. And, you know, again, I just, you know, you can do the derivative at this point. Try to save a little time. Okay, so it does work out. The generator is, in fact, the antiderivative of this function. Okay. But again, I mean, there's nothing insane about this. What happens is when you're sloppy, you can make mistakes. Again, it's worth learning that lesson. Here's another one. Again, I'll give you some time. Pause the video and jump in and see if you can do this one. I mean, again, they're getting a little more complicated. But if you're following the procedure, you should be starting to get comfortable with this kind of thing now. Okay, let's see what we have. So again, I'm going to look at the function, and I want to put this in the appropriate form. I mean, certainly I don't like this on the bottom. Right? And again, I want to point out, these are the kind of mistakes I see on the exams. And this is the same as like that square root one earlier. This mistake is terminal. You've completely changed the nature of the problem. In fact, I don't know if it would work if you actually did this in any way. But you completely changed the nature of the problem here. Again, this is a fairly, I'm not saying it's an easy problem, but this is fairly standard. This is the type of problem you can see on the exam, on the final. If you convert it into something like this, I don't think it would work. You know, you say, well, the test was so hard. It wasn't. Was it so hard, or did you just make mistakes like this? So that's why this really matters here, okay? Okay. Well, what I want to do is I want to bring this up from the bottom because I want something to the powers, right? And moreover, I'm going to put this on the left because I'm thinking this is going to be my choice for G. Right? I think this is going to be my choice for G. Why? Because if I take the derivative of this, I'm going to get an x squared. Okay, I have to fudge factor it a little bit. But this looks promising. Again, we haven't worked the problem out, but it looks promising. It's in the right form. And again, I can't handle this with the basic rules. I have to use substitution here. I can't handle this with the basic rules. So again, you can give it a shot, I hope. Pause it and give it a shot. I'll continue, but you can pause it. So if I decide I'm using substitution, it has to fit into this template, right? Again, I want to emphasize there's no other choice, right? Now, what your book does, or a lot of people do, is they call g of x u. I call it y, but I mean, it's the same thing. All right, this is my template. And again, once you choose g, once you take your choice of g, everything else is fixed, right? Understand that. Everything else is fixed. Once you have g, you have gx, you have fy. Okay, so give it a shot. Okay, just matching it up, I'm going to take g of x to be this interior part, x cubed plus 1. And then again, no choice. If I take g to be this, g of x is 3x squared. Again, I'm not against shortcuts or not putting in the work like that. But again, in that last problem, if you missed doing the chain rule correctly, you made a mistake. So again, be aware. Every time you leave out steps, you increase the probability that you're going to make a mistake. That's my thought. Okay, so now I have to match this up again. Try it. If you haven't done it, keep pausing the video and keep trying it. I know it's getting a bit naggy, but Okay, so I need the 3. I'm going to put the 3 in and take it out. Right? And so I'm going to put the 3 on this side. So now I matched up gx. Right? Now I matched up gx. So that's the first thing. And again, I like the dot. It helps. I mean, I think it makes it clear. So our next issue is finding fy. Right? And remember, fy is everything that's not gx. Right? Everything that's not gx, everything to the left side of that dot is going to be fy. And now we need to convert everything, the variable, to y explicitly. Right? Again, this is in composition form. I just want the function fy now, fy of y. So we're going to use this connection, right, to eliminate y equals gx. That's the abstract form. And on the right side, we're going to use the particular form up here, right? And so notice I have constants times y to the power. And that's good. That's what I'm looking for. Okay, that's what I'm looking for. So now I have my function fy in the variable y. I'm going to substitute it up here on the y side of everything, right? X is to the left, y is to the right. So integrate this. Pause and do it. There's no flexibility here. I'll take out the constant. This is going to be the power rule. And then I'm going to just clean everything up. Right? Clean everything up. And now I want to go back to the left side where I have x's, right? And how do I do that? I use, again, this connection up here. Okay? And that's it. I mean, that should be it. I'll take the derivative now of this and see if I get back my original problem. So I'm just rewriting it. This is my generator, and I want to see if taking the derivative of the generator gives me back my original function. So again, you can try this. Right? Check your work. And I just, again, symbolically, I did it here. I didn't write it all out. Okay? But again, on a test, I mean, what are those points worth to you? Right? What are those points worth to you? Do you want to risk that you did it incorrectly or made some mistakes? You can actually check your answer here. Okay. Now this one, I guess, has a bit of a trick in here. And again, I want to point out, you very rarely integrate things using antiderivatives. That's a fringe idea to begin with. And then gimmicks like this, these are fringe ideas for the fringe idea. And you see people go in the tests, and this is the first thing you do. I mean, this is like last gasp effort. This is the last thing you want to do, right? This is not the first. So I'll help you through here. Let's see how it works. So far standard, right? I want x to be greater than 1/2. So what's under here is, I guess have greater than or equal to 0. But since I'm looking at the derivative, I want the interior. Anyway, I certainly want to think about this. Now, this doesn't work well, and this is my problem. If I take this to be g, that's not going to give me that. I'm going to have a 2, right? If I take that to be g, well, that's not going to give me gx because the derivative here is going to be 2. So what do? It's a problem. It's a problem. So let's just plow ahead and see. But I mean, yeah, you should be a little uncertain about this. I certainly am. But I can't do it without using substitution. So I either can't do it, using the evaluation theorem, using antiderivatives. I have to do it numerically or some form. Well, this is an indefinite integral, so we're just trying to find the antiderivative, so I can't do it. So again, let's look. It has to fit this template, and the whole key is your choice of g. So let's just go with our choice of g, right? Again, I'm going to separate x's and y's, just repeating the slide here. So I have to pick g. Now, you don't have a lot of choices here. So we're going to just go with g of x equals 2x minus 1, just because I don't have any other better options. I mean, you could try different things and see, but this is my best bet, right? Because I'm going to have composition of functions here. Well, it's inevitable. If this is my choice of g, I take its derivative, right? Derivative of g to get gx, it's 2, right? I get that. Now, again, understand, I have to have gx of x equals 2 in this problem to make it work. So just because I put the dot here doesn't mean, this is gx. So I have to put in a 2 and take out the 2, right? 1/2 times 2. And now notice, this is my gx of x. That's it. That's it. Everything else is not, by definition. Everything that isn't gx is fy. It is. Notice I just moved the dot over here. But if this is gx, everything else is not. Right? So I want to find fy, and that's everything else. Now you can say I don't know what to do with it. That's fine. But it is true. Right? You don't have the choice. You're stuck with this. And this is a bit of a problem, and this is, I won't say this is a gimmick, but it certainly isn't obvious unless you see it. I mean, maybe you have a lot of time to sit on a hill under an apple tree and think about this stuff, but I mean, let's just see. Now, the left side is fine. Just keep plowing ahead. We'll see what we can do. Now, notice, everything is now a function of y. You can't have anything over here that isn't y. That's what this says. You can't mix and match. Now, I know I can convert this to a y. Now, again, I don't want x's and y's in here. I can convert this to a y, but I'm stuck with this x. Now, do you see any other way you can convert that x to a y? Think clearly. I can convert this term to a y easily. Anything else on this page, I'm just saying, look at this page. Any other way you can convert that x and y. Any other way you can relate x to y. So I can convert the x to things with y. I'm thinking this box, right? So I'll just solve this box. Okay, so I'm going to use this in here, right? That converts the x's to y's. And this equation also allows me to write x explicitly in terms of y. So that gives me that piece. Notice I'm not mixing x and y's at all. I don't mix x and y's. Everything's x here, right? And everything's in the y here. So this piece comes from there, and this piece comes from here, right? You can't mix. This is where people make mistakes. Now, if I just persevere and multiply all that out, let me multiply it all out, it turns out to be this. Which is fine, right? It's constant y to the power plus constant y to the power. That's what I want. I'm not saying it's easy. And again, don't do this as a first resort. This is the last resort. This is the last thing you try if you're desperate. Now, I see people do the final, and they'll do this technique on every single problem on the test. So say there's 4 or 5 integration problems. They'll do this on every single problem on the test, and they'll get every single problem on the test totally wrong, right? I mean, this is not the first place you want to begin. This is your last-ditch desperation Hail Mary pass, right? So that's it. Now you can integrate this. So just to try it, again, do it. It should be straightforward. Pause and then, okay. You can do it in a lot of ways. I'll just take the constant out first, and then I'll break this into the 2, right? I want the big brackets to make sure I don't lose the constant. Actually, I have a typo, right? This shouldn't be here. This is outside and front, so this is a typo. That's not good. I'm not going to re-record it, so okay, we'll just have to deal with it. Now here I have it taken out, so I guess I fixed it implicitly, right? Because the quarter's out in front, so it shouldn't be in here. But now I guess I fixed it. So I'm using the power rule here. Again, I just copied and paste things, so sometimes, again, and I'm just cleaning it up, right? Clean it up. Bring the quarter back inside each piece, right? Distribute it to this and this set. Bring the quarter inside. I'm just cleaning everything, just cleaning it up, combine it, and then I want to convert everything back to the y's. Okay. So again, this was kind of a special case. That's how I look at it. I mean, you should really look at that kind of idea. This kind of idea we introduced here is really a last gasp effort. This is not something you want to do. And you want to try to, again, check and see that this actually works, if this is actually an antiderivative of this function, by going back and taking its derivative. Again, you can try. So again, I didn't put all the steps in. I didn't put all the steps in, but it does work. Okay, it does work. But again, it's worth trying and seeing and practicing the algebra. Okay, well, the new feature here is it's the definite integral. We haven't done some of these for a while. So how does this work? You do the indefinite integral first and get yourself the generator, and then use the evaluation theorem, right, to evaluate the definite integral. So give it a shot. Pause and give it a shot. Okay, let me jump in. Let's look at this. Here's my function. Again, they're telling me the domain here that I need. And I'm going to write it in this form. And this works in the more standard way, right? This is going to be my choice of g, and its derivative is 2x. So the x works out fine. We'll put in the 2, fix the 2 later. Right? We can do that. There's no sense. I mean, again, you don't need to do it all right now. We're going to work it out. I'm just trying to see if it works, if I'm making the correct choices, trying to make things easier for myself. So I have to, well, I guess you don't have to use substitution. You could just cube this, multiply this all out 3 times and multiply it by x. It would be a 7th order polynomial. The algebra for that is not maybe easy. So maybe this substitution, even though you could do it in a standard way, maybe substitution is a little easier here. But if I'm going to use substitution, again, I have to fit this template. Again, I don't have any flexibility. I have to select g, and that gives me gx and then fy. Again, if you haven't done it, pause and try it. All right, I'm going to separate the variables. So I'm just rewriting now. I have to guess g, and in this case, x squared plus 1. And then I get gx automatically. Again, I'm not writing out all the lines anymore. Again, it's fine, and you should always think it. So like that previous example where we had to use the chain rule in there, and maybe you missed that. But, I mean, I'm not against just writing the minimum data. Just, again, you should be aware. Every time you leave something out, you risk a mistake. I have to put a 2 in and take it out, right? And then I'll separate the problem. So that's my gx. Everything else is not, right? It's not. Again, pause if you need. So now I'm going to find fy, right? So I'm just clearing it up, cleaning it up. So again, everything that's not gx is fy. I mean, that's just what it is. So again, doing the substitution, y equals gx, I get this. Again, I'm not against shortcutting a little bit. But again, be aware that you're risking things if you are. But I mean, again, look, this is all I have. So I put it on the right-hand side, integrate that, take out the 1/2, integrate. Again, I just put the steps here quickly. And that's it. And I can check my answer again. That is my generator, right? Its derivative should give me back the original function. So this is the antiderivative of this derivative. All right. So now I have the usual evaluation theorem. So I can do the definite integral by using the evaluation theorem. I simply evaluate the antiderivative at both sides and plug in. Okay, why don't I put a lot of effort into the definite integral? Because all the work is the indefinite integral, right? I mean, all the work was in the last piece. This was easy. This is the easy stuff. Okay, so that's it. Okay, so this is one group of problems. In the next lecture, okay, these were all substitution rules. Right? In the next one, substitution, in the next set of problems, I'm not going to tell you whether it's substitution or not, and you're going to have to do more combined problems. So we'll pick that up then next time. Okay, good luck.